Alright guys, welcome back. We're going to be solving another question from the third chapter of Mechanics of Materials by Johnston. We have question 21, and a torque of magnitude of T 1000 Newton meter is applied at D, as we can see, and knowing that the allowable shearing stress is 60 megapascal in each shaft, they're from the same material, so same shearing stress, we need to determine the required diameter of shaft AB and shaft CD. So we're going to be dealing with the elastic torsion formula that we talked about over and over. So the maximum shearing stress is equal to torque times the radius of the shaft over J, or moment of inertia. Since we have a solid shaft, the moment of inertia would be 1/2 of pi times the radius to the power of 4. And if we just put that in here, we can simplify this formula. The maximum shearing stress will be 2T over pi c cubed. And since the question is asking for the diameter, we can find the radius first, and after that we should be able to find by just multiplying the radius by 2. So here our c would be, or c cubed will be 2T over pi times the maximum shearing stress, and if we do the third root of each side, we can find the c, or the radius, but keep in mind that the question is asking for the diameter. So now we need to figure out basically the torque in each of these two shafts, and from there we can find the radius, or the C. So let's start with the shaft CD, and looking at this, we have 100 meter torque applying at point D, which means the internal torque in that member is going to be 1000 Newton meters. So let's see what we get for the radius of CD. 2 times T is 1000 over pi times the maximum shearing stress is 60 megapascal. So 60 times 10 to the 6 Pascal, and let's see what we get for this. So the third root of 2000 over pi times 60 times 10 to the 6. Alright, so that's going to be our C, or the radius of the CD in meters. And if we just want to report it in millimeter, we're going to multiply this by 1000, which is going to be 21.97 millimeters. So that's the diameter for CD, which is the actually B part of the question. Now let's move on to the member AB. And one thing that we need to keep in mind is that the force that these two are applying to each other based on the Newton's law is going to be the same force, same magnitude, just in the opposite direction. For every action, we have reaction. So we know that the force in each of these two gears are the same, and based on that, we know torque is equal to force times the distance, which in here is basically the radius. And this force is the same in each of them. So the torque in member CD is equal to FCD times RCD, and the TAB, or the torque of member AB, is again same force, FCD or FAB, real doesn't matter, or AB. So since these two are equal to each other, we can see that if we just have the F alone, TCD over RCD is equal to TAB over RAB. This is going to be how we're going to find the torque in TAB. So our TAB, based on this, if we just cross multiply this, is going to be TCD times RAB over RCD. We know this one's 1000, and we have the information for the radius of each. So RAB is 100 and RCD is 40, and we can cancel this out. It's going to be 25. So the torque in AB would be 2500 Newton meters. The rest is the same. So that was the trickiest part of this question, to just figure out the torque when we have these kind of errors in the system. And everything again comes from the Newton's law. For every action, there is a reaction, same force, same magnitude, it's just in the opposite direction. So that's how we figure out the torque in the other member. So now we're going to find the CAB. Oh, one thing I forgot. We are trying to find the diameter in here. So DCD in here is going to be 43.9 millimeters. So that's the answer for the B part. Since the question is asking for the diameter, not the radius. So the third root of 2 times, this time we have different radius. So I'm just doing this formula again. Would be found in here. 2t over denominator is the same. Now let's just calculate this very quick. I'm just gonna put 5,000 in here. Now let's just multiply it by 2 since we are asked to find the diameter. All right, so it's 29.8 times 2, and the D of AB is gonna be 59.6 millimeter, and that's gonna be the answer for the A part. Hope everything was clear. Let me know if you guys have any questions, and you guys take care. I'll see you in the next video. Have a good one.